Hello fellow developers, hope you're having a great day. This is Andrew talking and welcome to the next video of series of videos about iOS coding challenges. In this video we'll be talking about one very important and interesting challenge called contains element. So let's start from the requirements. Write a function that takes an array and an element and returns true if element appears in the array. Given array is sorted. Array could be empty. So let's start from a simple version and then I will make some explanation. So here is our simple approach. As you can see, it looks very easy. We just have a for loop, and if we encounter that item equals the element, we just break the cycle and return true, otherwise we return false. And you may think that this was too easy, but here's the catch. Simple version uses linear search, which is iterative, and this is not the most optimal solution. Time complexity of sequential search is O from N, which is not that bad, it grows linearly, but remember the requirement that given array is sorted. This gives us a possibility to utilize much more efficient algorithm called binary search. Binary search is a widely used search algorithm for finding a specific target element within a sorted collection. It's a highly effective and efficient algorithm that drastically reduces the number of comparisons required to locate the target element compared to linear search. There is one crucial precondition: collection must be sorted. So for linear search, in order to find the element, we need to loop through the collection, look at each element and compare if this is the one we are looking for. If element is not present in the collection, in this case we need to look through the whole collection. This is going to be the worst case scenario. In binary search, we're taking a completely different approach. First, we look for a middle element of the array and compare it with the given element. If the middle element is greater than the one we are looking, we throw away right part of the array and look for the element only inside of the remaining part. If middle element is less than the given one, we discard the left part and continue the same approach, dividing array in half until we find the element or prove that it does not exist in the collection. Complexity of binary search is O from log n, which means that the execution time grows logarithmically with the size of a collection. Is it much better? Well, let's compare. Here's the table with collection size and time needed to perform the calculation. Let's assume that we need 1 millisecond to perform one calculation. So as you can see, for small collection there is not such a big difference. But for a collection with 1 million elements, we have a huge difference in a time to perform the algorithm. So now let's get back to the code and implement our optimized solution using binary search. Alright, so here is our optimized version using binary search. As you can see, first we add in a guard to make sure that our array is greater than 0. If it's equals 0, we just return false. Then we assign two variables for left and right. Then we're adding a loop and repeat it until our left pointer is less than right pointer. We're getting our middle element and getting the middle value. If our middle value equals the element, we just break the cycle and return true. If our mid value is greater than element, then we adjust our right pointer, otherwise we adjust the left pointer, and then we continue the cycle until we find the element, or just left element is gonna be greater than right element and we just return false. So this is it with contain element challenge and binary search. If you find this video interesting and useful, give it a like, consider subscribing to the channel if you haven't done it yet, and thank you very much for watching, and I'll see you in the next episode. Happy coding and goodbye.